General guidelines for switch and conduit positions are based on room height. Firstly, let's discuss the main switch. According to the National Electrical Code, the main switch should be located at a height of 48 to 60 inches, which is 122 to 152 centimeters from the floor, measured to the center of the switch box. This height ensures easy accessibility while maintaining safety and preventing accidental operation. Secondly, we will discuss the lighting and fan controls. For rooms with varying heights, the height of the lighting and fan control should be determined based on the average height of the occupants. A comfortable height range is 54 to 60 inches, which is 137 to 152 centimeters from the floor, measured to the center of the switch box. This height allows for easy reach and operation without stretching or bending. Thirdly, consider socket outlets. Socket outlets should be located at a height of 12 to 24 inches, which is 30 to 61 centimeters from the floor, measured to the center of the socket box. This height provides convenient access for plugging in appliances and devices. Now let's discuss aesthetic considerations for a 3-meter height room. The main switch should be 140 to 152 centimeters from the floor. Lighting and fan control should be 137 to 152 centimeters from the floor. Socket outlet should be 30 to 61 centimeters from the floor. For a 4-meter height room, the main switch should be 152 to 168 centimeters from the floor. Lighting and fan control should be 142 to 168 centimeters from the floor. Socket outlet should be 30 to 61 centimeters from the floor. And finally, for a 5-meter height room, the main switch should be 168 to 184 centimeters from the floor. Lighting and fan control should be 147 to 184 centimeters from the floor. Socket outlet should be 30 to 61 centimeters from the floor. These heights are guidelines and may vary slightly depending on the specific room design and layout. It is recommended to consult with a qualified electrician to determine the optimal positioning of electrical points. When positioning electrical components, accessibility and safety are paramount. The NEC guidelines prioritize these factors to prevent accidents and ensure ease of use. Moreover, ergonomic principles suggest that switch and outlet height should cater to the average reach and height of the occupants to minimize strain and discomfort. From an aesthetic perspective, consider aligning switch and outlet heights consistently throughout the building to create a visually harmonious appearance. The choice of switch and outlet plate styles and finishes can also contribute to the overall design aesthetic. In residential settings, coordinating these elements with the interior decor can enhance the room's ambience. In commercial spaces, consider durability and functionality, opting for robust materials and designs that withstand frequent use. Furthermore, consider future adaptability when planning electrical layouts. Anticipating potential changes in room function or equipment placement can save time and money in the long run. Installing extra conduit runs or junction boxes can provide flexibility for future modifications. Integrating smart home technology introduces another layer of consideration. Smart switches and outlets often require specific wiring configurations and may necessitate adjustments to standard installation practices. Consulting with a qualified electrician who is familiar with smart home systems is crucial for ensuring compatibility and proper functionality. Also consider local building codes and regulations, which may impose additional requirements or restrictions on electrical installations. Compliance with these codes is essential for safety and legal reasons. Regular inspections and maintenance are also vital for ensuring the continued safe and reliable operation of electrical systems. Inspect switches, outlets, and wiring for signs of wear and tear, and address any issues promptly. Replacing damaged components or correcting faulty wiring can prevent electrical hazards and prolong the lifespan of the system. Proper grounding is another critical aspect of electrical safety. Ensure that all electrical circuits and equipment are properly grounded to prevent electric shock and minimize the risk of fire. Grounding systems should be inspected regularly to verify their effectiveness. Surge protection is also essential for protecting sensitive electronic equipment from voltage spikes and surges. Installing surge protectors at the main electrical panel and at individual outlets can help prevent damage to computers, televisions, and other devices. Lighting design plays a significant role in creating a comfortable and functional environment. Consider the type and placement of lighting fixtures to achieve the desired level of illumination and create the desired mood. Task lighting, ambient lighting, and accent lighting can be combined to create a well-balanced and visually appealing lighting scheme. Energy efficiency is becoming increasingly important in electrical design. Using energy-efficient lighting fixtures, appliances, and control systems can reduce energy consumption and lower utility bills. LED lighting, for example, offers significant energy savings compared to traditional incandescent lighting. Consider the placement of electrical panels and subpanels for ease of access and maintenance. Electrical panels should be located in a dry, well-ventilated area and should be readily accessible for inspection and repairs. Proper labeling of circuits and breakers is also essential for troubleshooting and maintenance. When running electrical conduit, follow best practices for bending, supporting, and terminating the conduit. Use appropriate fittings and connectors to ensure a secure and watertight connection. Avoid sharp bends or kinks in the conduit, which can restrict wire pulling and reduce the conduit's capacity. Consider the potential for electromagnetic interference, or EMI, when routing electrical wiring near sensitive electronic equipment. Shielded cables and conduit can help minimize EMI and prevent interference with nearby devices. Proper cable management is also crucial for maintaining a neat and organized electrical installation. Use cable ties, clamps, and supports to secure cables and prevent them from becoming tangled or damaged. Leave sufficient slack in the cables to allow for future modifications or repairs. When working with electricity, always follow safety precautions to prevent electric shock and other hazards. Wear appropriate personal protective equipment, such as gloves and safety glasses, and de-energize circuits before working on them. If you are not comfortable working with electricity, consult with a qualified electrician. Consider the use of arc fault circuit interrupters, or SIs, to protect against arc faults, which are a common cause of electrical fires. SIs can detect and interrupt arc faults before they can ignite flammable materials. Ground fault circuit interrupters, or GFCIs, are also essential for protecting against ground faults, which can cause electric shock. GFCIs should be installed in areas where there is a risk of exposure to moisture, such as bathrooms, kitchens, and outdoor locations. Consider the use of occupancy sensors to automatically turn lights on and off in unoccupied areas. Occupancy sensors can save energy and reduce the need for manual switching. Daylight harvesting systems can also be used to reduce the need for artificial lighting by automatically adjusting the brightness of lights based on the amount of natural light available. Power quality is an important consideration for sensitive electronic equipment. Voltage sags, swells, and harmonics can damage equipment and disrupt its operation. Power conditioners and uninterruptible power supplies, or UPSs, can help improve power quality and protect against these problems. Consider the use of renewable energy sources, such as solar panels and wind turbines, to generate electricity and reduce reliance on fossil fuels. Renewable energy systems can be integrated into the electrical grid or used to power individual buildings or facilities. When designing electrical systems for healthcare facilities, special considerations must be given to patient safety and the reliability of critical equipment. Redundant power systems, backup generators, and uninterruptible power supplies are essential for ensuring that critical equipment continues to operate during power outages. Consider the use of explosion-proof electrical equipment in hazardous locations where there is a risk of explosion or fire. Explosion-proof equipment is designed to contain any internal explosions and prevent them from igniting flammable materials in the surrounding environment. Proper ventilation is essential for preventing the buildup of heat in electrical equipment rooms. Adequate ventilation can help extend the lifespan of equipment and prevent overheating. Consider the use of thermal imaging cameras to detect hot spots in electrical equipment. Thermal imaging cameras can identify potential problems before they lead to equipment failures or fires. Proper documentation is essential for maintaining and troubleshooting electrical systems. Keep accurate records of wiring diagrams, circuit schedules, and equipment specifications. Consider the use of Building Information Modeling, or BIM, to create a virtual model of the electrical system. BIM can help improve coordination between different trades and reduce the risk of errors during construction. Regular training is essential for keeping electrical workers up to date on the latest codes, standards, and technologies. Training can help improve safety, productivity, and quality. Consider the use of predictive maintenance techniques to identify potential problems before they lead to equipment failures. Predictive maintenance techniques can help extend the lifespan of equipment and reduce downtime. Collaboration between electrical engineers, architects, and contractors is essential for ensuring that electrical systems are properly integrated into the overall building design. Active communication and coordination can help prevent conflicts and ensure that the electrical system meets the needs of the building occupants. Finally, consider the long-term sustainability of electrical systems. Choose materials and equipment that are durable, energy efficient, and environmentally friendly. Design systems that are flexible and adaptable to future needs. And strive to minimize the environmental impact of electrical installations. These guidelines and considerations provide a comprehensive framework for positioning electrical switches, outlets, and other components in rooms with varying heights. By prioritizing safety, accessibility, aesthetics, and sustainability, you can create electrical systems that are both functional and visually appealing.